Let's start with morphs. So in 5.6, you can create blend shapes right in Unreal. And let's see how to do that. At first, you need to enable the plugin. It's called, let's just find this. Yeah, this one. Enable, restart, and you can continue with creating your blend shapes. Actually, let me duplicate this so we have a backup. Mm-hmm. And let me delete what I did here. Mm-hmm. So you have here this icon, Morphs. It's called Morph Target. So, yeah. And you are in this tool. It's not that comfortable. It's better to create blend shapes in Maya. But if you need to create something really fast and your character is really simple, you can do this right in Unreal. Let's see. Let's reduce some brush size. Even more. Even more. Okay. And let's give him some big ears. And what I noticed, they don't have this symmetry enabled. So if I want to copy this ear to the right ear, I don't have such an option. Maybe it's a bug. But if I need to give him two big ears, I need to paint this separately. They will not be symmetrical in this case, but we will try our best. Okay. This one is smaller. Okay, perfect. Accept. This disappeared, and this went to the morph targets. So if you don't have this window, it was somewhere here. Let's just find it like this. Morph, yeah. Window morph target previewer. And guys from my project know we have this with the shoes. It goes into blend shape, and you can adjust it with a slider. Let's give him another one. Let's just save. With Unreal, especially with Unreal 5.6, save all the time. Okay, let's paint another one. I want it a bigger brush. Yeah, like this. Why not? These tools, well, okay, let's leave it like this. Accept. Uh, well, that was not planned, that it went to, to one blend shape. Okay, let's give it another try. Let's let's not select this, and let's paint one more. Okay, faster this time. Okay, so if you select the morph, you are adding it to the same. I don't want it. So let's deselect this. This was for his nose. Let's create one new just for the ears and deselect this. Okay. Okay, that should be fine. Then what we should do, we should rename them. So this one for the nose. Nose blend shape. And this one for the ears. Okay. And then what we should do, we should go into curves. And as you can see, you already have here some curves, but we need to rename them. Rename this. Just copy, put it here. And this one is for the ears. Also copy the name and put it into the curve. Okay, and as you can see, you have here a checkbox for morph target. If you don't have this, just put it on. And that's all for the skeletal mesh part. Then we should create a control rig. Let me create a new one. Create. Hmm? And let's create here a main controller. New element, new control. We will rename it for root control. Let's just choose circle. You don't have to do this. I'm just doing this to, to visualize it better. And what we can do here, we can right click on root control and add new element, new animation channel. This is not control. This will sit under your root control here on the bottom. And let's name it. Also, I just realized it a couple of days ago, but for Unreal, F2, in all Unreal, it renames everything. So if you don't want to just right click, rename, you can see it F2, F2, and you rename it right away. It will be ears. And let's do the same for the nose. New element, new animation channel, F2, nose. And let's change the minimum and maximum value. So let's put here minimum checkbox 0. Maximum, let's give here 50. And here is the same. Minimum 0, maximum 50. Compile and save all the time. And we have forward solve. And we have a note that curve value. You will have, let's just see, yeah, here we will have the curves that your skeletal mesh has, and we will edit them. So let's choose ear blend shape, and let's take our ears, get our animation channel, and plug it in here. And let's do the same for the nose. Get and plug it in here. Compile, save, and let's see. So we are selecting our control. We have our ears. Yeah. Why do you have so large ears? Okay, so actually, blend shape works from 1 to 0. From 0 to 1, yeah. But you can give it bigger values. So 1 to 0, 0 to 1, 1 will be your blend shape that you painted. But if you will put let's say 50, it will exaggerate it more. And if you, let's say minimum minus 50, it was for ears, right? For ears, minus 50, it will, yeah, it will do like, it will exaggerate it, but on a minus side. So it will push our ears in his head. Let's just change it to 0. And that's all for the blend shapes. Is it comfortable to work with blend shapes in Unreal? Definitely not, especially with the current brushes that they have. But again, if you really need something quick and fast and just simple, you can do it in Unreal without any other 3D software. Okay, so these were morphs. The next update, I just close all of this. The next update will be Locomotor. To work with that, again, we will need, let me find this plugin. Yeah, so you need the plugin enabled Locomotor. Again, enable this, restart engine, and you are ready to go. Create a control rig. Control rig, create. The first character that I will show you will be a bird. So I created the control rig from scratch. That's why I don't have any skeleton here. I can import the hierarchy here. Yeah, let's bring in our bird. And let me just grab some nodes from the ready asset. It will not be the locomotor, it will be just some fun stuff. Okay, not that. That part. I will put here a sequence, and in A node, I will put our locomotor, and in B, after all of that, I will put some dynamics, and we don't see anything here for now. But if I select COG control bone, control bone transform, and just watch his tail. Yeah, it's just more fun, but you don't have to do that. It just, so I'm taking all the bones for the tail, a lot of them. Just, grabbing here, like drag and drop here and create item array, but for the tail, and put in local chain dynamics node with such settings, and that works right away. Okay, let's move it here, and let's add a locomotor. So we are adding this node. All of this sits in just this node. And we have some settings. And for all of the system to work, we will need locomotor and something that can actually move your legs. So for that, let me just grab okay, full body. You can use regular transform, like set transform. You can use IK for 3 bones, like legs, but I would use full body IK. That also works. So, what we should put into locomotor? We should put a root control. We don't have it yet. Let's create it. And before we do this, what I noticed with some different rigs, it's better not to create controls like this. So you select your root bone, new element, new control. No, please don't do this, because yes, root bone should be pretty the same for all the rigs, but it's not. Just trust me, it's not, especially for rigs that you can find on Fab. So the safest way is to just click on empty space, right click, new element, new control, F2, Locomotor, control. You can name it whatever you want. For me, just more comfortable to use it like Locomotor name. Um, Maybe it's a bug, maybe it's something, but you cannot do it like this. So you can't put it with this arrow. You should always choose Locomotor from the drop down menu. It's highly experimental yet, and they are still working on these locomotors. They are still fixing some bugs, so please keep that in mind. Yeah, so we put here the control. Oh, let me just change the shape of this. Circle thick, scale. Yeah, 5 will be good. Next, we will need pelvis. Pelvis bone. It will be COG. Okay, here it works. Let's close this for now. So we just specify the pelvis. That's good. And foot sets. I'm adding it here. So foot sets, it means that if you have like character with 2 legs, you will have 1 foot sets and 2 feet. So each foot set is 2 feet. If you have if you have 4 legs, you will have to create like 2 foot sets, and each of them will have 2 feet. I have only 2 feet for this character, so I will delete the second one. And 1 foot set and 2 feet inside of this. Let's specify the ankle bones. Bone, and for this character, it's ankle left and ankle right. Okay, and another pretty funny stuff that if you don't select here what you're looking for, you will not get this list. Ankle right. Okay, and something happened right there. The upper green box is for pelvis. The lower, well, I don't know what where the lower is, but the upper is definitely for pelvis. And you have white circles. White circles is I can't call it collision because it doesn't collide with anything, but it just shows you how locomotor sees your legs. So if and its collision radius it's called, yeah, like that. So for this bird, it has pretty small legs, so I will put 3 and it will be good. Okay, and you have also this black circle with this line, and it tells you in which phase you are. So each phase, like each circle of this line is 1 step forward with 2 legs. Let's just close this for now, and let's remove our pelvis just to better see it. And also you can draw the bug, you can just deselect it and you will not have all of this. And let's move our dynamics even lower. Okay, so let's remove this. And let's see what's happening. Mhm. If I move, it moves these white circles. So what Locomotor actually does, it calculates how and where your character should place the feet and the pelvis, but mostly the feet. And let's put here pelvis, bone CLG. Okay. If I put here pelvis, it will move the pelvis, but not the legs. Let me enable this. Yeah, as you can see, legs are stay the same and they are clipping with the floor, but the pelvis moves. Let's draw the book. And what Locomotor outputs is the array for the feet. So these white circles, um, the transforms of these white circles go into this array. And actually, these transforms we should take and put onto our legs. And we will do this right now with full body IK node. Let's plug it in. And full body IK needs root. It will also be COG bone. And the bones go into a factor. So let's add. We will need two because we have two bones, two legs. The first one, the 0 1, will be ankle left. Yeah, and what's also important is that array will output the data in order that you put it here. So if you put the first one was left ankle, the output like 0 element of this array will be also left ankle. So yeah, so we should copy the order of these bones into our full body IK. And let's put here ankle, right. And let's get transforms. So to get just one element from an array, we use add node and we specify the index. So 0 index is here. And we just duplicate this and we put here index 1 and it will go here. Okay. And what I also would like to do, save, of course, save, but also in settings, in subiterations, I will put 20. What Epic told and what users on the internet told, subiturations will make your animation smoother. But what I see when I hover on this, I see that it works on subchains. And what that means, I just put it here. So we have two legs, and let's put here chain depths 2, and here 2 also. So for both of our legs. And it means that if we open our seagull, and if we go into the skeleton tree, and if we find our ankle bones, okay, let's do it this way. So ankle, and we have 1 and 2 bones upper our ankle. So chain depth is 2, and that's why we put it here. Okay, and we cannot see our bird because of the bones. And what I also found pretty interesting. So if you go here, and if you Control Shift and click, for example, on none, you have it here. And then again, bones, Control Shift, click on all hierarchy. It will also go here. And you don't need to go here. You can just click it from here. But the disadvantage of this, that it will disappear after you relaunch editor, and probably when you relaunch Control Rig 2. So you will need to do this again. But anyway, it speeds up the process. So we put here chain depths. Let's disable debug draw and see what we have right now. She walks. Okay. And she rotates. Okay, we will set it up. It will be better. What I also like to do in full body IK is to change the root behavior. So the best option that I tested was pin to input. That means, and it will be more visible on the next character, but pre-pull will rotate your pelvis. So it will just hover onto this. No? Worked. it worked previously. But okay, pre-pull will just compensate the pelvis rotation based on the legs position. So if your legs like move in, it will move and rotate the pelvis too. Pin to input will not do anything to your pelvis and it will be pinned. And free does some crazy stuff. It will rotate your pelvis like really fast. And, uh, some guys on the internet worked with free and it worked okay with them for them, but for me it never worked. Oh, I just found it. Yeah, so you have here some description. I just check. Okay, pin to input. Yeah, it looks just to the input pose. So I just leave it like that. And let's see some other settings for the locomotor node. Let's just close everything so we can go one by one. Movement, minimum step length. Um, Again, it's what you see. Minimum step length. This bird is quite small. Like the scale of this really small. So let's put here 3. Again, you just need to test and see what works better for your character. Speed max. Again, really small character. Let's reduce it to 60. Speed minimum. Let's put here 5. And well, other settings are not that important, but for the next character, we will reduce the face speed max to 2. So if you reduce this, your character will be walking slower a little bit, but it can help. For this character, let's just see how it works right now. Okay, we will set everything up. Uh-huh. For this character, we don't need this setting. So let's see, foot sets. In foot sets, you have max heel peel. It's how high your heel will go. I will not adjust anything for this character. It just works okay. And each of the feet in your foot set has this parameter phase offset. We will need this on third character that I will show you today. So basically, if you put here like two pair of feet, your feet will be moved synchronized, and you can just offset this this moment. Okay, let's delete it for now. Mm-hmm. Step in. The only setting that I adjust here is step high. I can put here, well, again, small character. Let's use 2. She will clip with the ground. That's okay. But again, step high, it means what it means. How high the leg of your character will move up. For the small character, small numbers. Anything else? Well, I didn't notice that they do anything, so I never touched them. Let me just check. And pelvis. So this clips with the ground. And that happens because of this bob offset. Google told me that to bob means to go up and down and pretty fast. And Unreal and Locomotor tells me that the amount to lower the pelvis and minimum height in a cycle. So it just moves your pelvis up and down when your character walks. Let's just reduce it to -2 for this character and see how it works. Okay, it still clips. Let's see if we did everything correctly here. So we put chain depth. Oh, I know why it's happening. Okay, let's finish with Locomotor first. So we adjusted bob offset. It helped with the clipping a little bit, but not fully. So it Mm, it moves the pelvis less than previously. And you can see that when the character starts moving, it just sits down. It happens to all the characters in all the tutorials, so it's just something that you need to live with. Yeah, so for the pelvis, that's everything that I adjust. Bob offset. Sometimes you can adjust also bob stiffness. So if you put bigger values, let's see, it's range from 1 to 100. So if you want your pelvis to be even more stiff, you can put here higher values. And what's comfortable that you can just hover onto any parameter and see some short documentation. Let's save. And so why the legs are clipping is because we didn't put any bone settings. And let's do this. Bone settings. So all the like movements of the leg you put into effectors, and bone settings, it just means what it means, settings for the bones. And we need, let's see, we need a knee. So we need to tell that this character can bend her knee this way. Let's just check. Plus Z plus. Okay. So we should specify the bone. It will be knee. And here the order is not important. So you can put right knee first. It's just bone settings. And use preferred angle. Open preferred angles. And let's put like 90 here. It doesn't matter if you put 30 or 90, it will do the same. And that's all. Let's just duplicate this for the right knee. Right knee. Okay. Use prefer and just double checking. Okay. Now we should bend our legs, our knees. Okay, it doesn't clip anymore. And it works. It works like that. And it rotates. Okay. Yeah, you can see some clipping here when rotating, but that's something that we should live with. And she works. Also, there was one setting. I just save. Okay. There was one setting. Let's just find this. Yep. In movement styles, walk, trot, gallop. Sounds promising, but it doesn't do anything. I tried different settings and it just does nothing. So not for now. Waiting for for later releases of Locomotor. And that's all for this bird. Let's see another character. Okay, let's create here another control rig. It will be for many. Mhm. Let's again import hierarchy, many. Save. Okay. And let's do what? Let's create root control again on empty space, new element, new control, F2, locomotor control, not color, but shape, circle, thick, scale. Okay. Compile, save. And again, create locomotor. We are putting here locomotor control. We are putting here pelvis bone. Pelvis bone. And we are putting here feet. Again, 2 feet. So 1 foot set, 0 and feet 1 and 2. And let's add bone. And for mining, it will be foot left and right. The size is okay. I will not reduce the size of white circles. Yeah, again, it doesn't do anything for now because we need full body IK. Full body IK. And let's do the same. So the algorithm is the same for all the characters. We are specifying the root. The root here means pelvis. Pelvis? Yeah, it's called pelvis for many. Effectors, we are adding bones here. The legs, foot left and right. We are grabbing our array and put and transform into our feet. So it was 0, and we should also take the first and put it here. Let's see. It's always better to double check. So let's see the bones, foot. Okay, so knee will be cuff and also two chain depth. We just close this because Teams will not allow me to see everything. Okay. So I will put here right away the chain depth 2, and here also 2. I will put sub iterations 20, again for smooth result, and I will put bone settings half, left and right, and let's just see which way it should rotate. Again, plus Z, and for the right leg it was the same. Conf, so I use preferred angle, Z90. And let's just duplicate this and put here cuff right. Let's save and see without the bug. Yeah, that's what I told you about the pelvis. He walks in a really strange way. He's rotating his pelvis a lot and the rest of his body, and he, well, he's doing so small steps. Let's fix all of this. The most annoying thing for me right now is pelvis. So let's fix pelvis first. I will go here and I will change the setting root behavior to pin to input. And let's just check how it looks right now. Yeah, he stopped doing this, like rotating, but he goes down a lot. So you can definitely see that he sits down and starts to move his legs. So let's adjust this bob in pelvis. Bob offset, let's put, well, he's bigger, so maybe -4. Okay, -4 works great. What else we will adjust? Let's start from the beginning. So minimum step length, his steps are so short, so we should increase that. Let's try 20. Let's also increase speed max 100, and speed mean I prefer to lower this too. And let's see. Okay, we will adjust it further. Oh, and here goes the setting that I told you before. So phase speed max, the maximum phase speed in cycles. Okay, so let's reduce it to 2. And that helps a lot. Maybe let's try to put here bigger number. But be careful, if you put here the too big number, it will not go when you move your control. So maybe 30. Okay, we can live with that. Let's see what else we have. In food sets, we have okay, it was not in foot sets. I'm looking for the height of his steps. It was in step pen. Let's increase this to, let's say, 30 and save. Okay, 30 was too big number. Let's try 18. Okay, that's better, but maybe 16. Okay, 18. Let's leave this. And let's see. Did I put here subiterations? Yes, I put here subiterations. And pin to input root 2. Okay. I still don't like how he moves his pelvis. Maybe some lower number for the root. It also doesn't look good, so maybe -4. -3.5. Okay, it's okay. It can be. Yeah, it doesn't look that good. And what Epic tells you that you can do to make it look better, to play it on top of the animation. So just hide it with some idle animation. So let me just find where it was. Preview controller, use specific animation, and I liked it on idle with pistol. And let's see. Maybe just increase some. Okay, it can be better, but at least he works. It doesn't look terrible. Let's see how he rotates. Well, he rotates in a really strange way. Let's see the debug. Okay, so it can be because of this. Let's just try one more thing before we finish with him. Foot sets, and let's try to increase his foot collision to 12. Maybe 15, 14. Maybe it will help with the rotation. It will not. Okay. Let's try this. Okay, so minimum step length helped a little bit with the rotation. I just, yeah, remove this. Okay, that's what you can do with the many. How we can make him move. We can make him walk. It's not perfect. The pelvis is still too stiff, but if you need just a regular walk, he can do that. But let's see. Okay, it was just a small bird with 2 legs, many with 2 legs, but what else we can do? I will show you here. Again, the process is the same. So you create root control, you create locomotor node, then you create full body IK. Just if you have more legs, you are doing this for all of them. What's the difference for, let's say, this wolf is that he has more legs. And in food sets, he will have, again, 0 in 1. And You can see that phase offset for the first pair of legs is 0, and for the second is 0.75. This is number from Epic documentation. I tried different numbers, and this one works the best. And let's see. Again, he sits down when he walks, but he walks and he rotates, and he does it better than many. But his back legs are clipping when rotating, but okay. And if we remove this phase offset, let me just show it to you. He will move like this. So as you can see, his legs are symmetrical, like left, right, left, right. And to avoid this, to make them unsynchronized, we put here phase offset. But other than that, everything is still the same. So you put here root control for the locomotor, you put here pelvis, you change bob offset, and you reduce some settings here: minimum step length, speed max, speed min, phase speed max. Here, no, nothing here. In step high, yeah, this one I changed. And in full body IK, you put all 4 legs here, transform, you are getting this transform from the locomotor, and you are getting at 0 until 3. So you have 4 elements for 4 transforms for all the legs. And again, it's important to save the order. Wolf F L finger 0, Wolf L finger 0. And yeah, bone settings. Yeah, I put a lot of here. So just use preferred angle so he bend his legs. Subiturations. And here, chain depth, also 3. We are checking here. Let's just show the bones. So 1, 2, 3. So 3 bones are higher than our bone that we use in full body IK. So we are putting chain depth 3 for all of these legs. And that's all for the locomotor for the wolf. Okay, let's see this one. I think I liked it the most. It's just a lot of legs. If you were to animate this manually, it will. Oh, I didn't select the locomotor control. Yeah, so if you were to animate it manually, it will be a lot of time and efforts. But here, it works. It rotates, and this one rotates even better than all the other characters. It looks nice. It was quite time consuming to set all of this up because he has like 8 legs. So you need to manually put here all the legs. You need to find all the bones, you know, how they are called, put here in the right order. So if you like put here, let's say this one, but then this one, then this one, it will not work. So you need to specify them in pairs. This one and this one, then this one and this one. Then which one was that? You see, even now I'm more confused. So you need to be really careful with putting here all the bones and then putting them here in the full body IK. into the effectors. I didn't do anything for the bond settings for the spider. It works okay even without this. And to be honest, I was terrified by the amount of bonds I would need to put in bond settings. So, okay, let it not bend his legs that much. It still looks okay. And I was curious, what would Locomotor do if, for example, our spider was injured? Uh, he has only 7 legs. Yeah, not 8. So let's see what it does. So how did I do that? I didn't remove anything from the model. I just removed the bone from the third full sets. And yeah, so I specified the left leg, but didn't do anything for the right leg. And Locomotor can work with that. So let's see, it will be without this leg. As you can see, this one's still stiff, doesn't do anything, but other legs are working. He's managing, he's rotating, he's doing his best to, to live on his 7 legs. And he even walks. Mm-hmm. Okay. So even injured spider can live this life. Let's put it back to 8 legs. Let's not injure him. Okay, that's good. That's pretty impressive that it can do walk cycle in control rig, but how can we use in real life? And let me just open the level. And let's say I want to put our, who we can choose, seagull. Yeah, I guess seagull into this level. It will create a level sequence, and it will be going. It will be going somewhere and disappeared. I thought I did something wrong, but actually it's a bug. Epic are already working on that. So if you just drag and drop your character into this into a level, it will go away. The only the only way to make it work for now is to let me just find where it was. Okay, it was here. If you drag and drop your control rig into the sequencer, oh no, no, no. Let me just remove this one. Okay, now we are safe. So let me grab this control rig, drag it into the sequencer, and it appeared somewhere there. So let me delete all of this. Maybe I can hide this. No, okay, let's delete all of this. I will just not save it. Okay, here she goes. And now we can do something with her. So we can, move her. We should always animate the locomotor control, the one that we put into the locomotor. So let's say we put key here and we put another key here and let her walk. And if you go to the first key, it doesn't go there automatically. It needs to, to calculate all the movements. So if you scrap the timeline, it will go from scratch. So be careful with that. And she walks. So that's how you use it for now. Let me just delete this. Let me think. I will reopen the level. Do not to save all of that. Don't save because I will need that level. Okay, the seagull is gone. And what I also wanted to show you, some use cases from the internet that I found. I hope you will see my browser right now. I'm not sure if you can hear the sound. I will turn it off anyway. Just open YouTube. Okay. Some artist put a control rig onto this insect. And let's just see how impressive it is. I mean, I really like that example. Let me just move to another part. Okay, Locomotor. And let's see this. Yeah, this was impressive. Just look at him. Yeah, and this template that Dima showed, and this artist added these bugs here. And you have a game. Oh, and another mode. Yeah, a lot of insects here. Okay, I have another example. Let me just find this. Yeah, it was on Twitter because all of Epic developers are on Twitter. Yeah, this one. And they even show this in the presentation. So if you are just a single developer, if you are using Epic tools, you can post something on Twitter and you can be noticed by the Epic developers. Yes, so this bird use Locomotor. And let me just show you another example. Oh, this is the same song. I need to use another link. Yeah, this one. This is also cute. So from what we see, it works cool for small, cute characters like these, like birds. And no hand animation here. Yeah, just Locomotor. Yeah, she looks cool. If you need to create something quick, that can be useful. And that was all, but not for our lecture, but for Locomotor. And if you have any questions, let's ask them in the end of the lecture, because we still have physics. Okay. To work with physics in control rig. So, guys from my team, we are working right now in that way that we create Physic Asset, a separate Physic Asset, then we put it into animation blueprint, and that's how it works. Epic introduced a new way to work with physics, and I will show you, well, I will show you 3 ways to work with physics in control rig today. To do this, to work with physics, we should enable plugin, which is called, let me just check. This one, physics control. So you enable this, again, relaunch, and you're ready to go. What you should know about the physics in control rig. It's highly experimental. Please don't do actual real projects in this because epics are still not using this in Fortnite. I've never seen that they are using this. Maybe they are using this on Witcher new chapter, but there was no information. So it's still highly in process. It's not comfortable to work with, but from what I see, from Epic presentation and from what they are writing in our internal chats, this is the future. That's where they are going. That's what they want to introduce, and that's how they want to change their pipeline. Okay, so we enable the plugin. And let's go with the first way of creating physics. Um, Okay, so I will create a control rig. Again, our favorite control rig. Let's call it physics. Listing hack. Because here we will be working with the Physic Asset. Let's import our character. I forgot how it's called, so let me just. Okay, it's called Beholder. I hope it was this one. And what we should do, we should find a Physic Asset for that. Let's just check this one. Okay, so what we have here, the body is kinematic and all the tentacles are simulated and they have collision with the body. You can see it here. So if I choose two of them, I have only disabled collision. That means that it's enabled. And it has this little, not tentacles, but some weird stuff, some pimples. I will not do anything with these because they are too small to be simulated. So all the tentacles are simulated without much, without any, any settings that we usually do. We can live with this. Or if you really want to make a beautiful character, you can put all of these like mask, damping, everything. But let's work with that. So to work with that, we will need two events. We have forward solve, and we will need construction event. And let's do it like this. Save again. The first thing that we should do is add basic solver component. Plug it in. And owner, well, owner was, let's put root here. So physics solver component is just hide bones. I will do this again. So to have this physics solver component is something that is the core logic of all the physics. So it just exists. You need to add it and it just stays, and that's all. If you go here and show components, you can see that you created physics solver and it sits under the root. And let's see what we have here. We specify where we put our solver. It's like where it where it will start from, where it will, do all the calculations. And we have some settings here. I never touched this. So for my characters, for my projects, I didn't change anything here, but maybe sometime you will need to change the settings. And these are like global settings. So when we are working in animation blueprints, you can choose that where to put the origin of your physic body, of your rigid body node. For example, if we are working with the skirt and we want the physic body to work from the pelvis and not from the root, so it will work better. Or if we are working with the hair and we put the origin in spine or in, in the head, that's the setting. But automatically, like by default, it's component. And let's leave it like this. So you can have space bone, then you specify the space bone, for example, pelvis or head or world. I will leave it with component. And you have here gravity, but it's like the gravity, like overall gravity, the global setting for the gravity, the collision, but for yeah, as you can see again, some hint from Epic that it's a collision with the space, with the ground, with the walls, with everything. I will not put here anything. And yeah, a lot of different settings which we will never touch. And some simulation space settings. And again, these settings are for all the simulation. So it's not for specific bones, not for specific bodies, but for the like world. Let's not touch this. Let's save. So we have our solver. We somehow need to put here our physic asset. And to do that, we should use the node. It's called instantiate from physic asset. And we should specify which physic asset, which file to use. Beholder, I'm just looking how it's called. Beholder. Yeah, this one. Quite pretty name. Okay, compile and save. And it will not work because we will need to put the solver. So this is our solver. This is our world settings. And we should specify that we are working in this solver. So just open the solver settings, visit solver component key, and just, you need to specify the bone where it sits. It sits under the root bone, and the name physics solver. If you have a lot of going on in your graph, you can promote this to variable and just plug it in. But I will not have much in this file, so I will leave it like that. Okay, let's see. That's all for the instantiate from Physic Asset. We plugged in our solver and we plugged in our Physic Asset. Close this. Okay, yeah, to better test it, let's create a new control. Have to root control, or not root, maybe. Okay, let's leave it with root. So, and yeah, I just saw that forward solve was here. Just remember that all of this that we are creating solver and grabbing our file in construction event, not in forward solve, but before we do all the logic. So in construction event. Okay. Again, I'm creating control node from the root because this character has some strange, root offset. So circle stick scale. Okay, no, 10, 15. Okay, 15 will work. And as you can see, my control is here and I want it to be here. And if I move the shape location, like 15, it's not visible because of the ground. It's under the ground. So my control will be here, but the origin will be here. So I don't want that. I will put this offset. It's not renamed. I thought I renamed this root control. Okay. So I will put this offset into offset location. Let's see. And if I compile, you will see that it's here. The origin is here. Maybe a little bit lower. It will not change anything, just for me to be more comfortable with this control. And let's make control to control our character. I'm creating in forward solve. I'm creating parent constraint. And I will use root control as a parent. Why I'm not doing this with set bound transform? Because I moved my control. So my root control and my root pawn are in different places. So it's better to work in such a case with a parent constraint. And I will choose root control here. Okay, and let's just check. Okay, so we have our solve, we have our physic asset, we have our parent constraint control, but it's not moving. Like all of these tentacles are not moving. That's because our solver needs to be solved. Yes, and that's what I meant when I told you that it's not that comfortable to work with physics in control rig. You need to keep in mind a lot of stuff. You need a solver and you need to solve this, and why the solver can't solve itself, why I need to solve that, isn't it solver? So, okay, let's just create solver for the solver. Um, mhm. And let me just check. It was, yeah, it was called step physics solver. And this node will solve this one for us. So put here. Again, we need to specify which solver we are solving. It sits under the root bone. Yeah, and you can see that it works. Mhm. And let me just check visualization. Yeah, it was here. So uh, in this solver for the solver, I can turn off the visualization and it will be more visible. They are moving. You know, if we rotate, everything is colliding with itself and our character works. Okay, what we can change here? In this node instantiate from Physic Asset, where we put our Physic Asset, we have simulation space control data. And we have parent space. Again, Epic didn't really write anything about it or didn't explain anything. It's from what I tested and from how I understand it. Parent is again from parent, so it from parent bone, and simulation space is like overall settings. So parent didn't work good for me, but simulation space worked okay. So if I put here simulation space control checkbox, otherwise it will not work, I can set up some things here. So like linear strength, let's put here 5. Let's put damping 2, angular strength 5, damping angular 2, and let's see how it works. And it stops moving because these numbers are too high. So let's reduce to 2. And as you can see, yeah, it works like that. It moves, but a little bit. So you can just play with these settings. Okay, maybe 0.5 here for damping. Okay, it moves better. It's more reactive to the movement. Let me just check. Okay, but if you want to adjust anything, you can do it in Physic Asset, or you can do it in code. And that's not that comfortable because you need to change the settings using nodes. But you can do it, it's better than nothing. So, and if you want to change any setting, you are working in forward solve. And let's just see. Let's take the skeleton. Let's just see how this bone is called. Okay, I need to turn on the bones. I want to take this tentacle. It's A01. Let's just turn this off. We will take a look at this later. Tentacle 01. So let's grab all of them. Let's take an array and let's do for each. So for each of these tentacle, we are doing, let's change the gravity for all of them. Set gravity. Yeah, set physic body gravity multiplier. So for each of them, we are doing this. And we are putting which for which bond. So when you are specifying your physic asset here, you have outputs, and you have outputs for body component key, joint component key, everything. Here we need to specify physic body component key. They are here, so you can just output it from here. Or we can just get bones and do it for the bones. Item, name, and we will need to specify it here. So you can either do it from here, body component, or do it for the bones and put them here, and it will find the automatically. And again, you need to specify the, let's compile, to specify the, okay, it's not working. Let's just put it here and it will work. It should work. Okay, let's leave it like this. It was working. Let's just change the gravity to, say, 0. Okay, let's do it in another way. Let's do it before the physics solver. And we will do it in another way. We will put it here. We will put here sequence. We will do step physics solver the latest, and we will put here this. Okay, so it doesn't work. Let's see why. Let's try to put here. Oh, we can't take all of these because here we will have all of the bodies. So we will have tentacle A, tentacle B, and all of the tentacles, and we need only these tentacles. Mm. Mm-hmm. Let's just unplug this and yeah, bone. Let's say what if. Okay. Yeah, and now we have it here. It's a body. Let's say physic body. Yeah, now it works. So for some reason it was not working until I plugged in just the you know the bone itself, and then choose here the physic body. And from what I see, it works only for just one of these. Okay, but okay, let's leave it like that. So you can use this node. It doesn't work perfectly, as you can see. Maybe it doesn't work perfectly with this one. Yeah, but you can adjust gravity. And you can adjust other settings too. You can adjust, let me just grab them. Yeah, this one. Yeah, so you can adjust gravity. You can adjust physics body data. So for that, you can, let's say, you can say that one of them, one of the tentacles is kinematic and others are not. Let's try to do it here. Let's try to plug it in. Okay. Because I plugged into the wrong part. Okay, so with this node, you can say that again, tentacle A 1, 2, 3, 4 are kinematic and have no collision, but everything else will be grabbed from our physic asset. So we have our physic asset and we are overriding some settings for a specific set of bonds that we are using and that we are grabbing here. Also, we can adjust some dynamic properties. So we can adjust mass, adjust center of mass, adjust linear damping, angular damping for specific bodies. And we can set physics control data. In here we have linear strength, linear damping, linear extra damping, so dampings and strengths. And we can do it for one body or one bone or for a set of them. Okay, so that was pretty much it for the physic asset. And what if we don't have physic asset? What if we have nothing except from the control rig? Let's create another one. Let's just duplicate this one and rename it. So we are not doing it from existing. We are doing it from control rig. Mhm. And again, I will delete these. I will not delete parent constraints, but I will delete this setting. I will leave and I will delete this. So I leave in only physics solver component. So it's the global setting that we have. Our global solver in construction event. I'm leaving parent constraint for my main control, and I'm leaving solver for the solver, so step physics solver. And then remember we had here instantiate from physic asset, and now we are at basic components. And that means that we will be adding our bodies. So everything that we made here in Physic Asset, we will be adding manually in control rig by code, by these nodes. Again, we should specify the solver. Oh no, it's owner. Solver. Yeah, it was here. Specify the solver. It's under the root bone. Solver. Compile, save, and it gives us an error because we don't have any owner. Let's create bodies for this, oh no, for this tentacle. Again, I'm grabbing an item array. I'm doing for each of them. An element will go here into owner. And let's see what happens. It falls down. And that works like that because we don't have any kinematic bodies. So all of these bodies, all of these tentacle bones are simulated and they don't have anything to grab. Yes, they can be constrained to anything. And we need to create this first. So I will copy this node like that. And in owner, let's just give the body and let's let the body be the kinematic body. So for that, we are looking for body data. You can see simulated. We are changing to kinematic and let's collision enabled. And let's find where we specify the how it will look. So in collision, Let's create a sphere. Let it be like 50, maybe 45. And let's compile to see it. Okay, let's turn on visualization here. And we have it. So this is our body for the kinematic body. So we created kinematic body. Then we are creating simulated bodies. And let's see how it works. We have it. And it's going crazy because we didn't specify the collision. Let's do it manually. So let's create capsules. Let's do it like that. Radius, let's say 4, length 2. Okay, it's better. It's still rotating. Maybe 5. Okay, and let's turn off the visualization and see. Okay, sometimes it's going crazy, so just it's still in process. So okay. And let's do one more thing. Let's create a node in articulation data. And let's put it here. So by that, you can adjust some settings. And as you can see, you have here angular strength, and it stopped rotating. So we can have 5 or 4 or like 6. Yeah, so by this setting, we are just changing it, how it behaves. And the disadvantage of this approach is that if you want to create dynamics for all of your tentacles and you have plenty of them, you need to do all of this like a lot, or you need to create a big array and put all of this here. But that's how it works. And again, you can adjust all of these settings. Adjust body data with collision type. You can adjust some mass or center of mass. You can adjust strength, both linear and angular, by putting these nodes after all of your logic. And let's see the last way how you can create all of this. So I just have this. Again, duplicate this. And call it manually because it will be fully manual way. Let's delete this. So the tentacle that we were creating. Let's delete this. This was the kinematic body that we created for the body, the big eye. And let's create our solver. So the only thing that we have here is the parent constraint and step physics solver. And if we enable show components, we will have everything here in hierarchy, and we can create all of these manually. So we can right click on root, create new component, physics solver component. It's here. We cannot see it, but it's here. It's just the main logic. And you can adjust all the settings right here in details. Yeah, you can see gravity and everything. Then we were creating the bodies, the kinematic body and the simulated bodies. Let's do it. So I'm selecting the body, right click, new component, body component. It falls down, but that's because it's simulated. So I'm going into this physics body. I'm going into detail panels, simulated, kinematic. It doesn't move, it just stays here. Okay, and let's find our tentacle. Let's create bodies for our tentacles. New element, new component, body. and it will fall down. Why? Because we have our kinematic body, we have our simulated bodies, and it still falls down. That's because we have only bodies. And if we go, let's say here, then let's just see. It has plenty of stuff. It has body, it has joints, and it should have some other settings. We will create them manually. So joints are our constraints, and without constraints, it falls down. So now we need to select our tentacles and new component and joints, and it's still here. Now, if we want to adjust some settings, we need to again select all of our tentacles, new component, and add. So we added body, added joint, and we need to add control component. And here we have linear strand, linear damping, and everything else. So let's just do one. And it behaves differently. So you see it behaves like from Physic Asset, while when we created it from just from the code, it just behaved like that. So the gravity was looking better for all the tentacle, and here it just like that. Let's see, angular like that. Yeah, so it moves, but it moves like that. So yeah, if you want to change anything here, you just select. It gives you more control because you can change like settings for one by one. So for, let's say, tentacle 5, I want linear strand 1. And for tentacle 4, I want linear strand like 10. I can do it. And it's faster. It's easier than if I were to do it like with the nodes. So you can choose the way you like better. But yeah, here you need to control everything manually and add everything manually. And these nodes are adding, no, these nodes are adding all of these here for you. And we don't have this. Let me just add this node. How was it called? Yeah, make articulation drive data. Just see if you put it here. Oh, because it's not, because it's from Physic Asset. Okay, yeah. So it should be here. So yeah. So when you are doing it from code, not from Physic Asset, you have all of this. So physic body, physic joint, same space control, and parent space control. So when you are creating it from the code itself, you have all the parameters to adjust. And then from Physic Asset, only like 2 of them. And let me just show you just one more thing, which looked interesting. Let me just find where it was. Okay, it was here. So, as I already told you, that joints are constraints, and you can create joints, which means constraints, separately. So, when we are in regular way on our project, when we are creating, for example, hair, and we have this hair, like hair, and we have left part of this, and we have the middle part of this, and we have the right part of this, we are creating horizontal constraints so these parts are not going far away from each other. This one creates the same for physics and control rig. So if I move it right now, you can see that these two are constrained. So I took, let's say, tentacle 5. It disappeared. So let's just show bones. I took this and I took that and I constrained them. So you specify the parent body, you specify the child body. You can also specify the stiffness, damping. You can add also limits, as we do have in our regular physic asset. And for example, I want to limit for x to be limited like 2, and other axes will be unchanged. So I can do that. Yeah, but it will look like this. And let me just show you how it was used on another asset. And this use case is quite useful, I think. So they had this rope, and they created constraint between them. Yeah, again, if you want to find some interesting stuff for Unreal about their new features, it's good to check Twitter and LinkedIn, because Unreal developers are using these two platforms the most. Yeah, and this one was on LinkedIn. Yeah, and you see that they are not constrained too close to each other. They have some limit space. And the really last thing, let me just show you just one more character. They show this kraken. Will the Twitter allow me to do it like that? Yeah. So as you can see, he has locomotor on his legs. He has dynamics on his tentacles, and these tentacles are controlled by one controller, which is circle and which is going like up and down and scales up and down. I hope you see it. It was not a good idea to try all of this on this character because he's too heavy. He has a lot of vertices. He has a lot of bones, and even my working computer can't process it quite smooth. But let's maybe turn off Locomotor. Maybe it will be easier for him. Yeah, so you can, yeah, you can see that it's lagging, but it works, and it works as they showed it. So you can rotate all the tentacles at once. You can scale them. So you scale the control, and the tentacles are not scaling up and down. They are just following this control. And you have separate controls for specific tentacles. So how was it done? Again, they have a lot of bones. So they are creating this physics solver component. Then for each of these tentacles, a lot of them. Okay, it was not the beginning. Let me just find the beginning. Okay. So these are the base. Let me just show you. So they have like the base. Yeah, so I took the base and I made all the base joints kinematic. That's why the array is not too big. So I'm creating kinematic bodies. Then, when this is done, I'm creating simulated bodies, and there are a lot of them. And this is not even the end of the array. So I needed to grab all of these, like this, and this, and this, and for all the tentacles that he has. And that's why it takes too much memory and everything and efforts for Unreal to process all of this. Just creating simulated bodies for that. And to be able to control the final, be able to control the tentacles like that, all the final bodies, bones are kinematic. So for this long array, I took everything but the last So the last I didn't include in my array. And I took all the last joins for all the tentacles and put them here into physics component, into kinematic. So the last bones are kinematic, and I'm creating controls for them here. So I do it procedurally just to make it faster. So I'm creating controls, these cubes, for all the last tentacles. And then some parent constraints, some constraints, and in the end, I put just step physics solver for that. And that's how it was done. Yeah, just test it again. Okay, it's hard for him. And what I also didn't mention that how it works, that control is scaled down, but the tentacles are also scaled down, but not, they moved, but they are not scaling down. Is that in parent constraint? Let me find this one. I think it was this one. Not this one. So there's a lot of going on. Let me just find main tentacles. Not here. Okay, but I will just explain how it works. So in parent constraint, when you do parent constraint, you turn off the filter, scale filter. So you turn that off. So you have only rotation and translation, and scale doesn't scale the tentacles. So they are just following the shape, but they are not scaling down themselves, like the tentacles. And it moves like that. And that finally was it.